in a diet mode, which is related to mastering the multimeter. This lesson goal is how to examine the charging line by diet mode. Okay, this is our goal in this from this episode, and how to examine any line with the diet mode, how to determine like is there is a shorter ground or there is a cotton line. We are going to know all of this by diet mode. Mastering the multimeter is one of the most used measure during our work in a diet mode. Okay, when to use the diet mode: to check any component on the battery circuit. You are just going to check on the battery line. Okay, it will be from 300 to 700, so it means that this is working well. Okay, and this is when we are going to speak about the charging line. Okay, you will understand this probably. We are going to measure a diet mode. Okay, on the battery line itself, we must get between 0.300 to 0.700, which means that this battery line is working like 100% well. Okay, measure any circuit connector like a power key, camera, and this is on battery connector, by the way, I forgot to tell you. We do this on the battery connector. Okay, measure any circuit connector on a power key, camera, mic, speaker, memory, SIM card. We know all of this. Okay, you will see in the schematic itself, it will tell you that this connector, like a power key connector or camera connector or mic connector, you must get like 0.300, you must get like 0.50, you must get whatever. You will see the value itself in the schematic, and you are going to measure it on the connector directly. So this is so vital. 5 measure on battery connectors only. 5 measure on battery connectors only. From 300 to 700, and the other side will be infinite. This means that the battery line components are working so well. Okay, this is the first one. Second one, less than 300 and the other part infinite. There is an unusual usage in the battery due to a water solution or a salt or whatever. So the solution of this will be to wash the board. So the solution of this is to wash the board probably if you get less than 300. Okay. The second one will be double value from the same side. Double value like 150 and 150, like the red one and the black one, both of them get a value. Okay, so there is a component on the battery. There is a component on a barrel is shorted to the ground. Okay, and solution is to use the short killer. So there is a short here if there is value in both of them. If there is both value in both sides. So buzz, which means short in all circuit root. If you get buzz, this is a full short. If there is a cut in series, infinite, like 0 OL on both sides. 0 OL on both sides. And the solution here is to use the microscope to check what is going on, which component is the reason of this cut in series. So it's so easy to follow. And all of these, guys, you need to save them inside your memory. So just bring a paper and pen and write all of this in a paper in order to save them inside your memory. You don't need to understand what is going on. You just need to save all of these measures inside your memory, because this is how you are going to work on the charge circuit. Any connector, if you get infinite, it means that there is a cut in series. Any connector, like I'm going to measure this connector here. If I get infinite in diode mode, it means that there is a cut in circuit. And the solution here is to use the microscope or to do bridge. Okay, if you get a buzzer, it means there is a short like 100%. If you get a buzzer on this connector, it means that there is a short like 100%. Okay, it's so easy, guys. And you will see here, this is on the schematic. It says that the value of diode mode here is 522. Value 520. Okay, you will see all of this when you use the schematic itself. It's so easy, guys. Wow, well done, dude. See you next lecture. So let's see how we can troubleshooting as Apple technician. Firstly, let's draw a connector where all our work will begin. Okay, all our work will begin from this connector. Okay. So there is a pin. There is a pins on the connector itself. Okay, sounds great. Every pin from this on the connector have a diode value. Let's see, this pin have like 425 value, 535, 322, 221, 322, 400, 500, 600. So how can we find a diode value here? We can find a diode value from a schematic. Okay, sounds great. So we are going to get our multimeter on a diode mode, okay, and we are going to measure. Let me get another color. Okay, red is fine. We are going to measure all of this in case if we didn't get a value, in any pin, the correct value, which means that the root of all this pin is not working. There is something issue inside this root which make the problem. Okay, so let's say we got here like 100. Okay, we got 100. It sounds like bad, 100. So there's a component not working inside this. Like let's draw the root here. Okay, there is a capacitor here. There is a capacitor here. There is a capacitor here. Then there is a coil. Then there is a resistor. Okay. Then this is what we had studied inside the hardware, and this is what we studied inside the hardware. This is what we studied inside the hardware. Okay, so here there is a capacitor, but this capacitor is on battery. So this capacitor is on battery, which is connected to the ground itself. Okay, we have studied what is the battery root and what is the series root, but let's write it. Let's change this one to, okay, this will be fine. So all of this root, is called series root, which is connected directly, okay, to the connector or to the IC or whatever. It's called series root. This one is called parallel, which is connected to the ground. So what if I got zero OL value, okay, or infinite? That means that the issue here will be on the series components. Okay, I will work directly on the series component. That means that the volt is got stolen inside the ground. So I will go directly to work on the parallel component here, which is parallel component, which is related to the circuit line, which is related to this line. Okay, sounds great. Sounds super duper great. So after that, I am going to make, how can I work on series components? Okay, as we have studied in the hardware course, we directly know how to measure the capacitor, the coil, the resistor. We know all of this. Let me give you something like a quick vision. We are going to do something called the volt measure. Okay, this is how we are going to test this one, like I just saw in the schematic, this one is carry 1.2 the line, and this one is just there is 3.2, and this one is there is like 4.1. So we are going to make a voltmeter here, okay, a voltmeter here, sorry, a voltmeter here and a voltmeter here. In case if we didn't find a volt here, okay, we are going to make a desolder to this capacitor. We are going to take it out of board. Okay, we are just going to take this capacitor out of board, and we are going to measure this capacitor to know is it this capacitor is working or not. We have taken this in complete details, how to measure a capacitor outside of board and how to know if this capacitor is not working or not. In case if we find that this capacitor is the reason, we are going to take this capacitor out of the circuit. Then we are going to add a new capacitor here, which will make the volt go again here. Then we are going to make our ultimate final step. We are going again to measure a diode measure here. Okay, in case if we found the same here, this value, which means we already make the problem solved. And this is exactly how we work directly step by step like Apple technician. This is how we work inside Apple company. I just give you like 100 tips and tricks. What's up guys, in this episode we are going to speak about power supply. The goal of this lesson to be a troubleshooting king. Okay, this is the ultimate way to deal with the power supply, as we have taken the ultimate way to master the multimeter. We are going to master the power supply just right now. So, short on board reading, click on the power key. If you get more than 2 ampere or the power supply is getting restart, it means that there is a short to the capacitor beside the IC. Okay, so if you click on the power key and you get 2 ampere or a restart in power supply, once you click on the power key, that means that there is a short beside the IC power. And as I told you guys, in all kind of this measuring, you don't need to understand. You just need to write it down and save them inside your memory and write them or somewhere on wall or wherever. Just let them in front of your eyes 24 hours, whatever you are going, just you are saying this, okay? I don't need you to understand, just save them. Boot without clicking on power key, you just get the phone is just boot without clicking on power key, which means that there is short on VBAT line, whatever it's Wi-Fi, Bluetooth, speaker, indirect short. Once you decrease the volt, it will stop direct short 0.0 on VBAT, which means, let me tell you, cut to the chase here. If the phone is got to power on without you even click on the power key, it means that there is a short on VBAT line. You are going to open the schematic and check where is directly the VBAT line in this, and go check by voltage one by one to know where exactly the voltage, where exactly the short is. Okay, pro note, use a multimeter on bus mode and you check the most component that surrounded the capacitor on VBAT line, or you can work on the bus mode. Okay, it's super duper easy, and I think that everything is going to be super clear here. IC power issue, okay, ampere less than 0.2, unstable load 0.2 and back to 0. Remove your finger on power key, it restart, directly went to 0. Okay, restart on Apple logo, power supply load 0 ampere, there is nothing more, 0 ampere. Short on power supply after clicking on power key. All of this are IC power issues. Okay, if you get all of this reading, that means that you have a real problem in the IC power itself. Okay, I think this is a clear as crystal. Okay, this is a clear as crystal, but you are going also to write all of this to not forget it. CPU issue, okay, ampere more than 2 ampere, then back to normal again, ampere more than 2 ampere, and LCD is working fine. Restart on first Apple logo, ampere so high after power click, it's a CPU or eMMC, so it check the capacitors around them. So how to know if it's a CPU issue or IC power issue or eMMC issue? You are just going to know this from a power circuit. You are just going to know all of this in a power circuit. I will tell you a way in power circuit episode to know directly which one to work on. because it's looking like same as IC power. They are looking like each other. They are looking like identical. Okay, EMMC and battery connector ampere more than 0.10, then back to zero again, then back to zero again. EMC or battery connector ampere pointer vibrates so fast, then it's EMMC. 1.6 high usage of battery and phone heating, short on the VBAT line. So you just need to read this. Just read this and type it down. Just put the video and type it down. Okay, software ampere will be less than 0.05, so it's a software problem. Okay, hanging on the second logo of Apple or any kind of any phone, it's a software problem like a 90%. So hanging on the first logo, then the phone shut down, it's a CPU or IC problem. Okay, IC bar problem. If it just pass the first logo and hang on the second logo and just close the phone, so it's a software problem here. Note, don't buy power supply less than 5 ampere because we need to inject board to determine where is the short exactly. So never ever buy a 2 ampere power supply. Thanks for watching, guys. Okay, our mental lesson today will be about troubleshooting mind. And this is exactly something also I have faced in my beginning, in my first 3 years in working in this field. Like once I see a hard problem here that I don't know how to solve this problem. This sounds so hard. What is the hell is going on here? So you need to make yourself feel enjoying while troubleshooting a problem. There is something I love to find a problem here. Okay, it's something so challenging. Once I solve this problem, I feel myself so great. I have muscle. Okay, once I solve this problem, I feel so great. And this is how we need to change our mind. Okay, just go every day inside this work. I need to find something I don't know. I want to learn. Okay, I need a hard problem. I need something like iPhone 14, iPhone 15. Hey, oh, it's okay. Just learn. Just increase your knowledge. And as I told you before, the more knowledge you increase, the more money you will increase. And this is the equation itself. So you need to change your mind. Once you are going to work inside this field, tell yourself that troubleshooting is something so great. I like to see problems. I like to solve problems because this is increase my knowledge and knowledge will increase my money, and this is how we do in this work. Change your mind. Right now, you need to be a troubleshooter. Just tell yourself that you love problems. What's up, guys? We are going to speak about schematics. The goal of this lesson to understand the type of schematics and how to use the schematics like an Apple team, and mastering the schematic is must. We can't prepare in a pro way without diagnose, roads, and circuits. So type of schematic, guys, is schematics show the root of circuit and the name of component itself on the layout diagram. We are going to see the image for all of this, no worries at all. I'm just going to read what is going on here, and we are going to use the schematic way. So important. This is we are going to use, okay, the layout diagram to show you the root of the circuit board itself, and this is so important. So also service manual, I don't use service manual at all, and this is solutions. This is, you can find here screws, part numbers, connectors, and this is how I don't use service manual. And plug diagram, which is the IC relations, and also I don't use plug diagrams. First type is called schematic. Okay, this is the schematic, guys, the most important type and the main one, because you can know the name of the component through this. We are going to know, like right now there's a problem in this capacitor. Right now I can know the name of this capacitor is C1704. If I go to Google and I just type C1704, okay, I will see a lot of websites where I can order this capacitor exactly the same. And I can also know from this, let me show you something here. We can also know like this capacitor can store 6.3 volt. Okay, we can see this here. And also we can see the value of this capacitor, 1.0 UF. Okay, we can also see this. In order, if we going to take another capacitor from another board, we will know exactly which value we are going to work on. Okay, so this is so important. This schematic is so important because we know the name from this. Layout diagram. Layout diagram is just like this, okay? After knowing the name of the component from the schematic, you can know where it placed on board through the layout diagram and the relation of this component one after it. So there is a problem I see as I take a board right now. Under the microscope, I see a problem here in this. I see a problem here in this capacitor. So I can know exactly where it find in the board itself, and when I click on it, I can see the relation route to this capacitor, where exactly this capacitor is going. So I can work on the circuit of this capacitor exactly. So the layout diagram is so important also. The block diagram is just the relation between IC and the components around it. Beginners will like this. We are intermediate, we are advanced, we don't use block diagram, and right now I know you have never worked it before in anywhere, but your level right now is an advanced. You are an advanced right now, you're not a beginner. Don't tell yourself that you are a beginner. Maybe you can use this, but to me, I have never used this before. It's called the block diagram, and it will show you the relation between the IC and all the components around it. Okay, it's good for beginners, which not good for us. So how can you use a schematic like pro? Whatever you are working right now in any kind of any schematic program, I will show you how exactly we are going to use it. Right now, I have a problem in IC charger, or I'm going to work in right now I have a problem in charging circuit, okay? As I told you, we are going to work from small to big. So we are going to open the schematic. This is called the schematic, the first type. Okay, we are going to open a schematic normally, then we are going to search about a charging circuit. Okay, this is what exactly we are going to see. The IC itself, then there is a relation about this IC with a capacitor here. This is capacitor on parallel, okay? Then there is the root on series. This is the series root. Maybe there is a capacitor here, and there is a coil here. There is whatever, okay? I just understand what is going on here. Okay, I just understand what is going on here. I am going to take this name of the capacitor, which is C1739. I will take this name, then I will close the capacitor itself, but I will take some information from this capacitor, like a volt, diode, and all of this measure. I will take them and I will write them in a paper or whatever, or I will keep this opened. Okay, don't close this page. Then you are going to open something called layout diagram. Okay, this is also inside the schematic layout diagram. You will take this part number here, okay, and just search. You will see like a search icon here. Just search with the search icon here until you see this, the same part number here, okay, the same one here, and you will see the same part number of this here, or whatever. You are going to click it in, and you will see, you are going to click on it, and you will see the root directly. Okay, after that you will know where directly to work on the real board, because the layout diagram is a real board. This is exactly how the board is looking. Okay, then we are going to work as we learned in measuring. Okay, whatever, if we're going to work in a diode measure, if we're going to work in a volt measure. So exactly, this is exactly how to know how the root from small, this is a small one, small, and this is a big IC. Okay, this is exactly how we are going to use it like a pro. This is how I use it. Whatever, no need to tell you. Just use like whatever schematic program name. Use this or this or this. But let me tell you that we are right now we are working to make our own schematic program. And once we have finished it, I will send you a mail, or you will see like we have upgraded our course, or we have updated our course. Because I promise you, we are going to make the best schematic. We are going to make the best schematic program in the whole world. Just wait, guys. Thanks for watching. Guys, don't forget to visit our website, cpu.academy, which you're gonna find a lot of courses inside there. And also you'll find a lot of helpful blog, which will help you in your repairing processes. So don't forget to visit our website, cpu.academy. What's up, guys? In today's lesson, we're going to speak about power circuits. So the goal of this lesson, how to deal with all power issues. That's just like Apple Team. I'm gonna show you how we deal with all of this kind of problems inside Apple Team. This is the ultimate way to deal with all power circuits issues. Okay, firstly, start from small to big, and this is so vital to know. you always need to start from small to big. Like you are going to start from the power key, okay, until you reach the IC itself. Because I see most of people just say, hey, there is a problem in power, just go directly to the IC of power, or go directly to the CPU, or go directly to the eMMC. This is completely wrong. This is why we have studied all kind of electronic components, and this is why we have understand what is the difference between series and parallel, and that is why we understood what is the cut in line issue and what is the shorted to the ground, to understand and to know how to work from small to big. Okay, and here small means the small component of the circuit, like capacitor, like power key, like capacitor, okay, like coil, like resistor, whatever. This is the meaning of a small. Big, like IC power, like CPU, like eMMC, which means in case if you got problem in the here, you need to start firstly in small and then to start go directly to the big one. So warning, let's read this warning. Warning, don't go to IC in the beginning. Always start with the power key. Use a test point to open a power. Use a test point to open power of the cell phone by using tweezer with the ground. I'm gonna show you this in next lecture, okay? In case if you have problem in power key and you cannot use the power key to power on the phone, we can do this by the test point itself, and I'm gonna show you how to do this just by using the tweezer, okay? If it is started, then it changed the power key. If the phone is started, then it changed the power key. And you can measure a volt on power key, 1.8 volt. 1.8 volt, which means that the power key is working, okay? So easy to do. We are going to start from small to big. Battery can be the reason. Always put battery in your mind, okay? Use a power supply and remove the battery from phone. If it launched it, so change the battery directly. Battery will be the reason. And the volt of the bat will be 3.7 volt. 3. Diode measure on two things. Diode measure. 3 diode measure to check if there is any short, okay, or cut in line. Just make a diode measure on battery connector and a diode measure in power key to check what is going on. And we are going to know exactly how to do this in a diode measure episode, okay? Diode measure episode. You will see directly how to make a diode measure on a connector of battery connector. You will get from 300 to 700. And on the power key connector, you will get a value from side and infinite from other side. Otherwise, if there is something not like this, so it is a big issue here, you will understand directly how to deal with this, okay? We are going to tell this in a diode episode. Components on a power area, okay? Power crescent oscillators, measure it with voltage, okay? We always measure this with voltage. Ref IC, CPU, NAND IC, and RAM, those are maybe the problem here, and the last step will be rebolting on the IC power, which we are going to see in the next lecture, how to work with the IC power, how to make a reball for it, okay? Note, power supply will tell you where exactly you are going to work at, okay? Power supply will tell you exactly where we are going to work in. And there is also an episode for power supply and episode for diode measure. There is a section only for just measuring the diode and measuring with power supply. There is a big section inside our course. Power common issues. Hanging on in first logo, it's a hardware issue like at 80%, while hanging on in the second logo, it's software issue like 80%. Okay, water damage. Sorry, let's go with the white LCD firstly. Check a new LCD one firstly. Okay, then check the software. Then it's a CPU or RAM or IC power. Okay, easy peasy, isn't it? Super easy. Super duper easy. This is on ultimate. This is everything you need to know about power issues. Water damage, clean a board with a Kai, then place it vertically, then dry it with the hot air. So easy. If it water damage, you just need to clean the board, okay, then place it vertically, then dry it with the hot air itself. So easy. If the phone dropped, firstly check the board under the microscope, what is going on. If there is something happened, then usually follow up way by multimeter in a voltage way and start to measure volt. Once you didn't see a volt in this area like 0 volt, it means that this is the issue, okay? Measuring in and out of volt of each component on the power circuit. So easy, guys. Super duper easy. Thanks for watching. See you in next lecture. First step, we need to know which power line is the causing of the problem itself. Is it the IC power or the CPU or the NAND? Okay, firstly we will connect the phone to the power supply. If we got an ampere more than 0.1, like 100 milliampere, that means that the IC power is working correctly. Okay, in this case we will accuse the CPU or NAND. So we will connect the phone to the computer itself. If the computer read the phone, this means that the CPU is working probably. In this case, we will accuse the NAND. So we'll do the software to the NAND. Okay, in this case, we'll do a software to NAND. If the software didn't work, we are going to do a reballing hardware to the NAND. This is exactly how we will work on all power issues. We need to determine, is it IC power problem or CPU or NAND? Okay, if it IC power problem, it will be on the power supply less than 0.1, less than 100 milliampere. So we will work directly on the IC power, as we will see here. So if it less than 0.1 milliampere, we will go directly in the second step to work on the IC power, is to measure a volt on a power key. Okay, this is a voltage measure, as we see here, 0.8 volt, which means that the power key is working probably. Okay, so let me show you how to power on the phone without power key. Just get your tweezers and add it on the power key connector, and the other part on the ground. As we see here, the mobile is just powering on without a power key. As we see on the power supply here, the mobile is just running correctly. And as we see 0.1, which means that the IC power is working probably. As we get a power 1.8 on the power key, also power key is working probably. So in the next step, we will just pressing on the IC. Maybe the phone take a damage or something happened to the phone itself. So we are going to press on the ICs, like the 3 ICs that we mentioned before, and keep your eye on the power supply itself. If the power supply go more than 0.1, this means that this IC is a problem. Okay, we are going to press on all IC, but just a light pressing. Okay, don't press so hard, just a light pressing. Then we are going to do a diode measure on a power route. Okay, as we see here. Okay, if we get a read on a diode and the other part will be infinite, this means that the route of power is also working correctly. Okay, in this case, the route is working correctly. If we got like infinite in both sides or reading on both sides, this means that the power route is not working. So this step is to make sure that the power route is working correctly, and in this case, we need also a schematic here. I will show you how to work without a schematic in next step. Okay, but this step is so important to just measure a diode on the IC route. In the last step is doing a randomly volt reading. As we see here, we're just trying to measure a volt around a CPU. As we see, there is a 3 volt here, which means that the CPU, the IC power is working correctly, and it gives the volt to the CPU. And this is randomly without any kind of schematic. We are just going to make a multimeter on a volt mode, and we are going to measure on a capacitors around the CPU and NAND to make sure that they take the volt from the IC power, which means that the IC power is working correctly. And this is a way also to make sure which one is the problem here, which one we are going to work on. Okay, this is also another way. We will see like 3 ways in this video to make it easier for you. Okay, as you can see, there is 1.8 volt here on the capacitor, which means that the IC power is working probably, and he gives the volt to the CPU. As we can see here on the capacitor, there is a volt here, and there is 1.8 volt and 1.8 volt. 3.2, it means that it's working like 100% IC power is working. Okay, the problem here will be between CPU and NAND. And as we mentioned in the beginning of this video, to know which one is the problem, we're just gonna connect the phone to the computer to know which one exactly is the problem here. Is it the CPU or the NAND? Okay, and if it's a CPU problem, it will be easier than the NAND, because most of reballing will be easier to the CPU. Okay, we are going to find a lot of reballing material to the CPU itself. We are just still doing the randomly volting measure around the CPU to make sure that everything is working fine around the CPU. And we are going to test also the same way around the NAND. We are going to measure the voltage around the NAND. Okay. It is so easy, guys. Just let's do it around the NAND. As we can see, there is a voltage around the NAND here, 0.6 volt. And 0.6 volt also. Okay, there is 1.8 volt here, which means also that the NAND take the volt. Okay, here we are. NAND, we got voltage measure. Okay, 1.8 again. It means that the NAND take the volt from IC power. So IC power is working like 100%. There is no problem in IC power route. It's working like 100%. And we just know that, okay, there is a 3 volt here. It means that the NAND take like 100% of voltage here. Okay, so IC power in this case is working probably. And let's see if we have the schematic here. The schematic show you directly where to get the voltage as we did. We did this in the randomly volt, okay? But if we have the schematic, it will tell you directly where to find the volt. Okay, this is show you exactly as we did in the random volt. Okay, there is a 3.0 volt here as we found it. This is how we are going to make. And in case if you have the schematic itself, we are going to follow a voltage like this, how it shows in the schematic itself. We are going to follow a component after the component until we didn't find a volt in this component, which means that this component is the main accuser of this problem. In this case, we are going to take out this component and we will replace. What's up, guys? In today's lesson, we are going to speak about charging circuit. Our lesson goal, how to solve a charging issue just like a bro tech. Okay, forgot about beginner solution because I don't like it. Okay, this is the most common issue you are going to get in your store, a charging issue. So please deal with this as a pro one. I forgot about all kinds of beginner solution. So this is the ultimate way to deal with all charging circuits problem. Starting from small to big, exactly as I told you in the power issue, we are going to do the same in the charging issue. We are going to start from the small to the big. Okay, make sure that you are using the original charger. So firstly, when the customer come to you, use original charger while you are testing this charging area. Okay, test another battery. Just test another battery because maybe this battery is the issue, or try to make it the test with the power supply. Take the battery, remove it away, and make an test another battery. Maybe this battery isn't accepting the charging anymore, so we need to add another battery and test with another battery. USB connector may be not working, and this is, we can know this. USB connector may be not working, and this is usual because adding the USB a lot inside this area, and you can see this by your eyes. You will know once you see the connector by your eyes that this USB connector is not working. Diode measure on a battery connector, this is your first step. And we have a big diode measure episode. We are speaking about this in details. Okay. Component can be the reasons. Capacitor or coil, Zener diode, MOSFET, BSI, SWE, NTC, B10, charger IC, all of this can be the issue. So we are going to use a follow-up measure, but we don't need to inject the root with 5 volt. Use a follow-up measure, but we need to inject the root with 5 volts by power supply. Then measure a voltage on each component in the root, which means we need to connect the power supply to phone, okay, like a battery itself to this phone, and we will get the multimeter itself, and we are going to measure a component by component. We are going in this way. If you need to use this way, we need to use the schematics. A schematic is must here. Open the schematic, go to the charging circuit and change and check which parts of this exactly have every volt. Like this one will carry like 2.2 volt. Where is this exactly, and where is this exactly? And you are going to follow by the schematic itself, and go to check one by one the volt on one by one, and everything is gonna be fine. The component that you will not get a volt on it, it means that this component just still the volt, so this component is not working. Just remove it from the board and just replace it. Note, no charge. There is a note for you. If you find no charge, so the problem on series, there is a cut on line here if there is no charge to the phone. If there is a fake charge or high usage, so the problem here will be on battery. There is a capacitor installed the volt here. So this is so important note. If there is no charge, go directly to on series. If there is a stall in charge or a fake charge, go to components on battery. Okay, that's related to the charging circuit. How it works on Android, as you can see here, a connector give to a capacitor, capacitor go to the MOSFET, a MOSFET send it to Tigris, and Tigris just send to BMU, and BMU go to VBH power, which already give the all components on board. Okay, this is how it works. This is how it works directly on the Android. And I forgot to tell you that this MOSFET just to tell the CPU that everything is going fine, and it just show the percentage of the battery itself. Okay, this is how it work on the Android itself. How it work on the iPhone itself, okay, 5 volt, it just go on capacitor, coil, Zener diode, it just go directly to the MOSFET. Is it got a charge? Yes, it's got a charge, so pass the volt to the TriStar. TriStar will pass it to Tigris. Tigris is the IC charger. Tigris will go to the CPU and IC power, and everything is gonna be fine. Okay, this is how it works on Android and on iPhone. It's so easy. As I told you, we are going to master the Android and iPhone together. No worries at all. You are in the CPU Academy hands. You don't have to be worried at all in this job. Thank you for watching. See you in next lecture. To measure diode on the connector itself, so we are going to get a board like this. It is so shaped, by the way. We are just getting the diode measure right here, as you see, a diode measure. Okay, we got all reading done, as we see here. If we get reading in all lines, that means that all the line on series is working correctly. There is no cut on line at all. Okay, in case if we got 0 AL in any kind of these lines, that means we are going to open the phone and we are going directly to work on this line. So this is how we can test the series line on the charger circuit without even opening the phone. This is our first step to do. And this board is so cheap, don't worry. Okay, this board is so cheap. It's gonna help us without even opening the phone. So our first step is to do a diode measure on the connector. Our second step will be also without tearing down the phone or without even opening the phone with the USB safety tester. Okay, let's get the USB safety tester here. As you can see, guys, it is so cheap also. Okay, we can just test what is going on inside this phone without even opening it. It will be like our power supply. Okay, it will show us is this phone is doing a real charge or a fake charge. Okay, it's doing a real charge because as we see here, 0.40 ampere, which means this phone is a real charge. In case if we get 0.1 ampere, like 100 milliampere, that means that this phone is doing a fake charge. Okay, in case if we get a big ampere, like 1 ampere or like 2 ampere, stuff like that, that means that this phone has a short. So this USB safety tester is gonna show us what we are going to do inside the phone without even opening the phone, okay? So this is our second step, is to use the USB safety tester and check the ampere here. Our third step will be by using the power supply, because it may be the battery is the problem, so we need to remove the battery from the phone itself and directly connect the power supply to the phone. In case if we get reading with the power supply and the phone just got powered on, it means that the battery is the main issue of in this case. In this case, it will mean that the battery is the main issue. Okay, as we can see here, we just connected the phone and we removed the battery. In case if the phone just boot, okay, as we can see here, the phone is working probably a 47, which means that everything has done its job. So the problem here, or the main issue here, will be the battery. We will need to replace the battery. So this step is a mandatory in case if we didn't find the solution with the diode measure, the first step, nor a USB safety tester, the second step. So this will be our third step to check if the battery is working or not. Okay, our fourth step here is to check the battery cable. Maybe the battery cable is destroyed or there is something happened to the battery cable here. So we are going to check if this cable is working probably or not. And nobody has telling this before. Nobody is doing that. Okay, I will show you probably how you do this. This is like a tips and tricks. Just Apple team who are doing something like this. So I'm gonna show you how to do this probably. Okay, firstly we need to find 5 volt on the battery cable. Okay, we will just take out the battery cable from the board itself. We will not remove it, just take it out. Okay, hold on, there is something here. Okay, we just need to find 5 volt. 5 volt on the cable. If we find 5 volt on the cable, this means that this battery. Okay, let's test it. Let's get the 5 volt here. Okay, this is the positive area. Let's give it another try. And make sure that your USB cable is connected to the phone while doing this. Okay, here you are. There is a 5 volt here, which means that the battery cable is working probably. We don't need to change the battery cable, and here how we are going to check it. Okay, it's super duper easy. There is no worry about this. Okay, in the next step we are gonna check all the battery root. Okay, in our first step, which was the diode measure, we just made sure that everything is working fine on the series root. So right now we are going to check the battery root. How we are gonna do this? This is so easy, guys. We will just get 5 volt here on the test point beside the battery connector. In case if we find the 5 volt here, which means that every single component on the battery root is working probably. As we can see here, we are going to get the 5 volt here, which means every component on the battery root is working probably. So now we have it checking the battery root, we have it checking the series root, and everything is gonna be fine. Right now we need to check the last step, which is the MOSFET, because maybe MOSFET is stolen a volt or stolen something which is not going to the IC itself. So we need to check if it's going well or not. So we will check a capacitor beside a tri-star in order to make sure that the MOSFET has done his job. As we see here, we got 5 volt beside the capacitor, beside the tri-star here. So which means that everything is working fine now. So everything is working fine. What is the only accuser of this problem will be now? It's IC charger, the Tigris or the IC charger. We are going to take the IC charger out of the board, and then we are going to make a reballing to it, as we are gonna see in the troubleshooting section, not now. Okay, but the IC will be the last accuser of the problem itself. And this is how we are going to work on the charging circuit. Super duper easy, guys. What's up, guys? In this episode, we are going to speak about Wi-Fi and Bluetooth. Okay, our lesson goal is to master the Wi-Fi Pro solution in the Chinese way of dealing with the phone Wi-Fi. So the root, the root of the Wi-Fi and the Bluetooth, it is IC of Wi-Fi, antenna, CPU, filter, and PMU. And remember, our way in solution is from small to big. Always remember this. Okay, how to check it? Diode measure is your best friend. Okay, diode measure is your best friend. Then the follow-up solution, as we have learned it in the camera. Okay, this as camera way. Check the filter damage volt, because this is the most or the common issue. There is a filter damage. A filter is looking like the coil, guys. Okay, filters and coils are one. Use a tweezer as antenna. Okay, this is a professional way. I don't like to use it. Check the IC of Wi-Fi, heating, and the last will be software if it Android. Okay, so before doing the software, you will check the IC itself firstly. iPhone 6 Wi-Fi in Chinese way solution. This is exactly where you will place your tweezer, and this is a brew, as I told you, the brew. You will add your tweezer here. okay, to make it used as antenna. So if there is something here, if it worked, so this is the problem and it changed this. But I don't recommend you to do this because this is a little bit professional, and it may be this filter the problem. Okay, it's always the problem. This filter is always the problem. Okay, this filter is always the problem. Just take out this filter, okay, and replace it with something else and it will work. Like I have dealt with the thousands of phone. I always find this filter is the problem in the Wi-Fi itself. This is the antenna, as I told you. Okay, we can make to measure this to this. This is the Wi-Fi IC, which may be the problem itself. We will take this IC out and replace it. When any phone has a Wi-Fi or Bluetooth issue, always try it on your Wi-Fi, because it may be the Wi-Fi of the customer doesn't support his phone type, or maybe it's a software issue. Thank you. What's up, guys? We are going to speak about camera circuit. The goal of this lesson to mastering the camera of iPhone and Android and the Chinese way of dealing with the phone camera. No worries at all. The ultimate camera. Okay. The root of camera. CPU, PMU, LDO, camera, connector. Always remember our rule in repairing: from small to big. From small to big. So how can we check it? We are just going to use a diode measure on the connector itself. We are going to the schematic itself, and just we are going to camera to check what is the diode value of the connector itself. If the diode value from, it says like the diode value is 0.123, so we are going to do the diode value. If we get this value, it means that everything is fine, so we will change the camera directly. Okay, follow-up solution like voltage. As we have learned, we are going to make a measure volting a component after component, voltmeter on a component after component. We are going to check a flash. Last step, we will replace a camera with a new one in case of that. Okay, and after replacing camera, if it's still not working, we are going to replace the connector of camera, and this is the last step. As we can see here, this is iPhone 6 diode measure. This is on the schematic itself. It will tell you exactly the value of the diode itself with the number of bin. Okay, we are going to get our multimeter and get all of this, like 451, 451, 451. In case if we didn't get this value or this diode value, we will check the root of this bin. Okay, what if I get like 420? Sorry, what if I get like 42 only, and it shows that this value must be 451. We are going to follow the root of this. There will be a root for this bin. Okay, like there is a capacitor here, there is a coil here, so there is whatever, and we know exactly how to know the destroyed one. Okay, we know exactly how to determine the destroyed one. We are going to take it out and change it and replace it with a new one. Then we are going back to check a diode measure. If it's 451, then everything is working fine and the camera will be working probably. And this is how exactly we work on with the diode mode. iPhone voltmeter, how we make voltmeter, as we can see here on the schematic. Okay, we can get 1.8 volt here. Okay, we can get whatever. Okay, the schematic is telling us exactly how to measure the volt, like 2.85 volt. There is a capacitor here. We need to check 2.85 volt on the capacitor. We need to check here 1.2 volt here. We need to check here. And this is how to work with the voltmeter. Voltmeter, guys, is so easy, but you need a schematic here. Okay, you need a schematic here in order to make sure that you are working probably on the right way. Okay, pro note here: when working with camera or any component that has a connector, first thing to do is to replace it with a new one. If it didn't work, then took all the steps that we have learned. It's so easy, guys. This is a pro note. Thanks for watching. What's up, guys? We are going to talk about mic. The goal of this lesson is to mastering the mic repair like a Chinese engineer. And let's see the root of this audio IC, CPU, RF IC, also PMU, MOSFET, and dock connector, exactly as the audio codec. How to check it? Exactly, we are going to use the audio correct way. Diode measure, follow up, then it's checking the MOSFET volt. It changed the audio IC software exactly at the audio correct, but there is here a MOSFET which is related to code. There is a MOSFET here which is a little bit different than the audio correct. Okay, this is how to check it. This is the IC correct. Okay, and this is a volt itself. This is a root of audio. This is a root of mic, as you can see here. This is the connector and all the components that go through. This is so easy. If you have the schematic, you will be able to work on the mic super duper easy, no problem at all. Okay, pro note, when working on mic, start with cleaning the filter of mic firstly if there is a weakened sound. If no sound, no, this is not now. It's no. If no sound, change it with a new one and test it before doing anything. Okay, just like working with the LCD, because 90% it's a mic issue. You don't need to work on the circuit at all. Trust me, like 1,000 of issues, and it was directly it was a mic issue. So you don't need to work on the IC or the component or whatever. It will be your last step. Okay, I just give you from A to Z. Okay, to cover all kind of problem here. Thanks for watching, guys. What's up, guys? We are going to talk about audio codec. So the goal of this lesson is to master the audio a bit like a Chinese engineer. Okay, sounds great. Firstly, let's see the root of the audio itself. We are going to work on audio IC, CPU, RF IC, amplifier, okay, connector in iOS, dock connector. How to check it? Always, they are the same, guys. All of them are the same. All of them are the same. Diode measure on the root as we have done in the camera, and follow up solution voltage, which we need a schematic here. Exactly the same. Okay, we are going to check the amplifier, the volt of the amplifier itself. Then we are going to check the RFIC connection with the audio, and the last step will be software Android. As we can see here, as I told you, as we did in the camera connector, the same. We are going to see here the diode measures. We are going to make a diode measure with the multimeter. In case if we didn't get this, then we are going to check the whole root. In case if we didn't get, then we are going to check the whole root. And this is the IC. We can measure IC diode also. We can measure a bin under the IC, but this is a painful, guys. This is really a painful. If you just remove the IC and check a diode under the bin of IC itself, but not the IC itself. You are going to check the bed of the board after removing the IC itself. But this is a super duper painful. So it will be better to check the root itself, okay, to understand what is going on. If the problem in the IC itself, then take out the IC, throw it away, and just bring a new IC. iPhone 6 audio volt measure, and this is how we make a voltmeter. We are going to open the schematic. We need to measure 1.8 volt here. We need to measure 1.8 volt here. The schematic will tell you exactly where to get the voltage to measure the volt here and also volt here. In case if there is no volt in all of this component, we will take those components away and just replace them, and it will work probably. Pro note, in some cases there will be a problem in hands-free connector, which may give a fake feel to CPU that you are connected the hands-free itself, so you don't hear any audio. Please remove the hands-free connector and test the audio. Okay, this is so important. This is so important, guys. Thank you for watching. After finishing this section, in case if you want to open your store, you will just need the same level in software and LCD glassworking, and we have another 2 courses that are related to LCD glassworking and software itself. So you can check up in the resources those courses. This is all you need to start working right now. But let's go to another section because it will help you so much, the micro soldering advanced.